Good morning, children. Welcome back to ICAN Physics. Now in this class, we are going to solve question number 22, which deals with the resistivity and the resistance. By using that, we are going to calculate the current. Okay, let's enjoy the class. So next, we will start the second question. The two rods are joined end to end as shown. Okay. So let us consider copper and iron. They are connected. Okay. Of cross-sectional area of 0.01 centimeter square. So both have. Okay. So now I want to go for copper and iron. So area of copper, it may be taken as A1 and it is 0.01 centimeter square. Now convert the centimeter into meter. So 0.01 into 10 to the power minus 2, the whole square. So 0.01 into 10 to the power 2 2s are 4. Okay. So I want to make it as a whole number. So what we can do? So it is multiplied by 100 and divided by 100. So 1, 2, 2. So the decimal point becomes 2 digit forward. So it becomes 1 into 10 to the power minus 4. So here we are having 2 0 goes to the numerator as minus 2. So 1 into 10 to the power minus 6 is the area. So many meters squared. Both have cross-sectional area of 0.01. So the iron and its area is also 1 into 10 to the power minus 6 meter square. Okay. Can you understand? Okay. Next, each is 1 meter long. Okay. So the length of the copper rod is 1 meter. The length of the iron is also 1 meter. Okay. With a resistivity of 1 rod is copper with a resistivity of. So the resistivity of copper, then it can be taken as rho 1 is 1.7 into 10 to the power minus 6 ohm meter. The other is of iron with the resistivity of 5 into 10 to the power minus 5. So rho 2 equal to 10 to the power minus 5 ohm meter. Here the power is in power minus 6. Here we are having minus 5. So to make it as common, it is multiply and divided by 10. Okay, minus. The plus 1 goes to the numerator as minus 1. So 10 into 10 to the power minus 5 minus 1. So 10 into 10 to the power minus 6 is the given. Okay. How much voltage is required? How much voltage is required? So what is the value of V? Okay. So to produce a current of 1 ampere. So current I equal to 1 ampere. Okay. So to relate these things, current equal to 1 ampere. Okay. So we need the value of resistance. Why? So V equal to I into R. So by calculating the value of R, then we can find the value of V. Okay. So to calculate R, how we can relate these things? Resistivity, area and length. Then we can go for rho equal to RA by L. Now we are having two cases, copper and iron. For that cases, we are going to calculate only the resistance. The division L comes to this side as multiplication L. The multiplication area comes to this side as division. Then we can calculate the value of R. So for copper, we can modify the formula. Okay. So R1 equal to rho 1 L1 by A1. Okay. Here R2 equal to rho 2 L2 by A2. Okay. So these two, copper and iron, are connected end to end That is, they are connected in series. When they are connected in series, then Rs equal to R1 plus R2. Now we can substitute the value. The R1 is rho 1 L1 by A1 plus R2, that is rho 2 L2 by A2. Okay, just to compare the area. Okay, A1, A2. So both are same. Both are same. Next, length. So the length is also same. So that how we can modify the formula. That is rho 1 into L by A plus rho 2 into L by A. Now L by A can be taken as common. So Rs equal to rho 1 plus rho 2. Rho 1 plus rho 2 into L by A. Okay. Now we can calculate rho 1. So what is the value of rho 1? 1.7 into 10 to the power minus 6 plus rho 2, that is 10 into 10 to the power minus 6 into L. L value is 1 meter divided by area. Area is 1 into 10 to the power minus 6. So 1 into 10 to the power minus 6. So here the minus 6 can be taken as common. Okay. The remaining 1.7 plus 10 divided by 1 into 10 to the power minus 6, 10 to the power minus 6. 10 to the power minus 6, 10 to the power minus 6 getting cancelled. Okay. So 10 in 10 plus 1.7. Okay. That is 11.7 ohm. Okay. Now what we are going to calculate? Voltage. So V equal to IR. Okay. Now what is the value of current? The current value is 1 ampere. Okay. 1 into R. R value is 11.7. So 1 into 11.7, 11.7. So that is the voltage. So this much of voltage is required. Okay. The same question, they asked for instead of ohm meter, sometimes they are asking ohm centimeter. If it is asked ohm centimeter, convert the centimeter into meter. So 10 to the power minus 2. So 10 to the power minus 2, minus 6, minus 8. So here we are having 10 to the power minus 8. So minus 6 goes to the numerator as plus 6. So minus 8 plus 6 minus 2. So that we can put the decimal point, 2 digit in front. So your answer may be this one. Okay. But here we are using ohm meter. So that our answer is 11.7 volt. Okay. Do you get it now? Do you need out?